Today, we will try to understand operations on a single linked list. So, recall single linked list is a collection of nodes singly recall there are three types of linked lists: singly linked list, doubly linked list, circularly linked list. So, singly linked list is a collection of nodes. For example for a singly linked list as shown here. So you can see it is like collection of nodes. Each node is having one data item and a link to the and a link. It is having the address of the next node. So it is an example for singly linked list having three nodes. And also remember the last node is having null. We will now in this session we will try to understand one of the operation like insertion. I mean the inserting a node in a singly linked list. So in fact, you can insert a node in a list at the beginning or at the middle or at the end. So we'll try to understand the different steps involved in these three cases. So inserting a node at the beginning of the list. So assume the linked list is created as shown here. That is having now three nodes. Head is pointing to the first node, that is 100 is the address of the first node, and the last node is having a null. So if you want to insert a new node at the beginning, first we have to create a new node. So we have to create a new node. Assume new node has been created at address 1000. Then we have to insert the data. Assume the data is 40. User enters the data 40 and 40 is stored in the data field. Then, so already you know this is the linked list, a singly linked list. Head is pointing to the first node. So now we have to insert this node in the beginning. To achieve this goal, so we have to write now this new node link field, new node link equal to head. As a result, you can see in the link, new node link equal to head. As a result, now this new node is pointing to the first node of this list. Similarly, we are making one more change. Head is pointing now the first node in this list. So we have to write now head equal to new node. As a result, now head is pointing to the new node. You can see a new node is inserted at the beginning. So these are all the steps involved in the inserting a node at the beginning of a list. So we'll try to understand the C programming first. I mean, we will try to now understand the C program to achieve the same. Yeah, you can assume like insert beginning SSL is a function. It will insert a new node at the beginning. So we'll try to understand the different steps in writing this function. The first using malloc, right? We are creating a new node using malloc at runtime. So the malloc will create a new node and returns that address. That address will be stored in the new node. New node is a pointer of right node pointer. So as a result, a new node is created. Assume it has been created at address 1000. So this piece of code asks the user to enter the data for this new node, and that whatever the data entered by the user will be stored in the new node data field. As a result, you can see here 40 will be inserted at the data field. Now we have to do this is the linked list. A linked list, the same thing, linked list. Now we have to do a few changes to insert this new node at the beginning. The first step is new node next equal to head. So new node next. So in this next field, we are making new node next equal to head. As a result, this new node next is having 100. As a result, it is pointing to the first node of this linked list. So now the next step equal to new node. So this head, in fact, it is having now 100. We are making changes head equal to new node. As a result, now head is pointing to new node. Head equal to 1000. It is pointing to new node. You can see this new node is inserted at the beginning. So these are all the steps involved in inserting a node at the beginning of the list. Now we will try to understand the different steps involved in inserting node at the end of the list. Assume the list has been created with 3 nodes as shown here. If you want to insert a new node at the end of a list, first we have to create a new node. Assume new node has been created at address 1000. Then we have to insert the data. Assume 10 has been inserted in the new node data field. So the new node should be at the end. So we are going to insert the new node at the end. So already the end node always having the null in its link field. So we have to check now. Suppose if the linked list is empty linked list, whatever the new node will become the first node for that linked list. So we have to check whether head is equal to null or not. If head equal to null, we have to make head equal to new node. As a result, new node will become the first node. Otherwise, assume the linked list is not empty. So means assume linked list as shown here. It is not empty. Assume we have to now traverse the entire list from head to here. So we have to traverse the list, and our PTR pointer will stop at the last node. Then we have to do necessary changes. The last node next field equal to, the PTR points to the next field. Now last node next field equal to new node. As a result, so it will point to the new node. So already new node, we have already inserted the null at the end. So you can see now this new node will be inserted at the end successfully. So these are all the steps in fact involved in inserting node at the end of the list. We will try to understand the C program to achieve the same. So this is a piece of assume here insert end SSL is a function that will insert node at the end of a list. So as like previous, we are creating a new node using malloc at runtime. Now new node has been created. Assume it will be created at 1000. Then we ask the user enter the data. Assume user enters 10, and we store in the new node data field. So then in new node next we are making null because it is going to be the last node. As you already know, the last node is having null always in a singly linked list. Now we have to check the linked list is empty or not by writing a condition head equal to null. So if the linked list is empty, we are making this new node as a first, right? So the steps here, head equal to new node. As a result, you can see head equal to new node. Now head is pointing to the new node. It will become a first node for the linked list. Otherwise, assume it is not empty list. Assume the linked list as shown here. We have to now traverse the entire list. You can see the code. We are creating a PTR pointer, initialize with head, starting from head. We are traversing traversing up to PTR next not equal to null, traversing up to the end node. So we are writing condition here, PTR next not equal to null, then PTR will move and will stop at the end node. Now PTR points to last node. We are now doing necessary changes. PTR next equal to new node. So PTR next equal to new node. As a result, the link field we are storing 1000. As a result, now this points to the new node. This points to the new node, and already new node we have already entered the null at link field. So we can see now a new node has been inserted at the end of a list. Now we will try to understand the different steps involved to insert node at the middle of the list. Assume the linked list has been created as shown here. Now we want to insert a new node after second location. For fair comparison with arrays, I assume here that linked list here also I treat it as the 0th node. Like array index starts from 0 in C programming for fair comparison. So I assume here like this is 0th node, first node, second node. I want to insert a new node after second node. That is the assumption here. So that's why here I have taken the location equal to 2. After the second location, I want to insert a new node. So what are all the steps involved here at the middle, assume, after a location, specific location. So first we have to create, assume, after one. Yeah. So I want to insert new node after the second location, after location 2. So as you see now the malloc function, as a result, it will create a new node and returns the address. Assume a new node has been created at the address 1000. At address 1000. Now the asking the user to enter the data. Assume users enter data 10 and the 10 is stored in the new node data field. You can see here 10 is inserted here. So now we initialize the PTR with head, and so we have to traverse the entire list up to end. PTR equal to head. So until PTR not equal to null and count equal to a location. So we have to traverse up to that location. So this piece of logic will help us to traverse the linked list up to location, up to specified location. So assume due to this piece of code, PTR will move and stop at the second location. So PTR will point to second location, right? Then we have to do necessary changes. So new node next equal to PTR next. Now PTR points to this node PTR next. PTR next is having 300. So new node next, we are making new node next equal to PTR next. We are storing the 300 here. So you can see here, in fact, so we are making it PTR next equal to new node. The second step is PTR next equal to new node. As a result, you can see PTR next. PTR is pointing here. PTR next, we are replacing new node 1000. As a result, the connection will be destroyed here and it will point to the new node. Similarly, see here new node next equal to PTR next. As a result, new node next here equal to PTR next. PTR, in fact, this next is having earlier 300. So we have already do necessary changes. So 300 is shown here, means this new node is pointing to this node, the last node of the previous list. So we can see now, we can observe now, new node will be inserted after second location. So we have to be carefully observe here the necessary changes. The necessary changes are new node next equal to PTR next. New node next equal to PTR. PTR in the PTR earlier pointing to this node. PTR next is 300. New node next we are making here it is 300. As a result, it is pointing to the last node of the list. Then we are writing one more condition, PTR next equal to new node. So PTR next, we are replacing to new node like 1000. As a result, the connection will be destroyed here and a connection will be established here. As a result, we can see the new node will be inserted after second location. So these are all the steps involved in inserting node at the middle of the list.